Okay, now we're going to build a reamer. This is also going to be used on the metrology sample. So hopefully we can reuse this tool on the metrology sample. So we're going to go to the tool library, and we're going to go to our aluminum library here, and we're going to copy a drill bit to make this reamer. And attached to our assignment, you have this sheet that's going to be for the metrology sample, which is another project you're going to cut. And we're going to be using this 251 thousandths reamer. It's got the critical information you need to build a cutter. This will be attached to this assignment as well. But we're only building up this one reamer for the moment. So we're going to go back to Fusion here, and in our tool library, we're going to take that 1/4 inch drill bit we just used, the 1/4 inch solid drill, carbide drill. We're going to left click on that, and then you can go copy, and then we're going to paste it back into the library. Now we got to be careful because we just made a duplicate of the same part with the same tool with the same number. We're now going to edit the copy, and we're going to change this to a 251 reamer. On the description, we're going to delete out Kennametal because I don't know what brand they are. The product ID and the URL we're going to wipe out. Under cutter, instead of a drill, we're going to switch that to reamer. Okay, in inches. I'm not sure how many flutes this thing has. It's probably around 6. Let's look at our data. Straight shanked. The stat sheet is for 249 reamer, but the geometry for the blank's the same, pretty much, length and whatnot. It's high-speed steel, so we want to set that in Fusion to be high-speed steel. Okay, and our diameter is going to be 251. Our shaft diameter is going to be the same as the tool diameter. The overall length is 6 inches. And the length below holder, we're going to put 4. Our flute length, let's go back to our sheet. Flute length is 1.5 inches. And the shoulder length, I think we can just leave that. Okay, and then we're going to go to shaft, and it's got a different upper diameter than the lower diameter. Typically, the upper diameter is smaller. We're just going to set it the same size. Okay, and our holder, we're just going to stick with the same holder we had for the drill bit. Under cutting data, we're going to use the data that's in our sheet here. So we want 2,300 RPM and 16 inches a minute. So that's pretty close. Okay, so a reamer feeds in and feeds back out. We're going to feed in and feed out at the same speed. So just to double check, it's 2,300. And 13 and 13. Okay, we go to post processor. It's critical we change the number. We're going to go to tool 19 on this. That way it doesn't conflict with anything else in the carousel. Tool 20 should be the probe. We'll go, this will make us in a safe zone. Okay, we're going to hit accept, and then we're going to hit close, and now we can go drilling. We're going to select the tool we just made, which is our 251 reamer. We're going to leave the default settings we just set on feeds and speeds. On geometry, we're going to select the countersink and the hole, and then we're going to go to heights, and we're going to go from model top, model top for retract, we're going to go from hole top, from the top height to hole bottom. There is no real tip to break through on a reamer. It is flat bottom typically. So we're going to do an offset of negative 0.1 hundred thousandths, and that should get us clear of the little chamfer that's usually on the tip of a reamer, and we'll have gone all the way through. Alright, so we're going to go to cycle, we're going to ream, feed and out, in and out. It automatically selected that because of the type of tool. Linking tab will leave that alone. Hit OK. So we've now reamed that out for a close diameter so that when we put our steel drill rod in there, it should be a nice slip fit. Okay, that's it for operation 3. Now let's do operation 4. Hide this instance of the vise, show the next instance of the vise. Let's get the vise so it looks like it's, parallel to the world. Okay, and then we're going to create a new setup. It's going to be setup 4. We're not going to use the model orientation. We're going to use Z and X axis. We're going to pick the top surface of our model. And then an X axis is going to be one of the edges. It's an X. Looks like we need a flip direction. And then we're going to go to either a stock or model box point. At this point, it won't matter. And then we pick the bottom edge of our parallel. What we're going to be indicating in on is this surface that I'm moving my cursor about. And the rest, our vise stop should already be set up at this angle. What's going to be important is you make sure that you get it seated on that flat on the parallels. Okay, we go to stock. That's from the previous, that's fine. We're going to ignore that. And then post-process, we're going to put our part number 7312. This is op 4. So we're going to put a 4 at the end. Program comment, op 4. And it's work order system 1. We're going to hit OK. We're going to change the name of this to op 4. And what are we doing? We're doing a countersink, a drill, and a tap, which we did on the first routine. So we're going to do a little bit of copying. So we have our deep drill, which was our spot drill, our tap drill, and then our tap. So you can select all 3 of those by holding down the control key. And then we're going to right click and say copy. You could also do Control C if you wanted on your keyboard. Go down and highlight with your left button operation 4, and you do a paste. And if you expand that operation 4, you should have the 3 operations we want. Now we just have to regenerate them on our new geometry. So I'm going to right click on our tool 15. Okay, we're going to take all this at default. Select our new geometry and hit OK. We'll move on to the next one. We're going to edit, go to geometry, we're going to clear the original selection, and we're going to pick our 2 new holes. So we're going to do the face and the through hole. Hit OK. And our last one. Right click, edit, we go to geometry, we're going to clear the old selections and then pick our 2 holes again. There we go, pretty simple. Alright, so we should be done. We are pretty much done programming this part. Make sure you saved. In reference to the previous videos, we need to fill out the traveler for the programming operations using the tool numbers so they can be on the paperwork for per operation. And then you need to submit a setup sheet and post-process code for 4 programs. So 4 setup sheets, 4 programs. Do not post-process all these as one program. They are different, discrete operations. You need to submit the hard copies with your final project for full credit, and you'll need them in the lab too. So I suggest printing them in the PDF if you can. I'm not sure if our printer can print to HTML. In Canvas, we'll take the HTML. Alright, so I'm not going to walk you through uploading all that stuff again. And thanks for sticking with me, and good job doing on a four operation part.